According to the 2020 National Electrical Code, the only conductors required to have pigtails, also known as tails, are grounding conductors, as per section 250.148b. This section, 250.148b, addresses grounding conductor continuity. Specifically, it states where more than one equipment grounding conductor is connected to an equipment grounding termination, a grounding conductor, firstly, shall be used to connect the grounding conductors to each other, and secondly, shall be sized in accordance with 250.122. Now, there are exceptions to this rule. Firstly, the grounding conductor is part of a metal raceway or enclosure that ensures grounding continuity. Secondly, the grounding conductor is part of approved flexible cord or cable. It is important to understand the role of grounding conductors. These conductors provide a path for fault current to return to the source, allowing overcurrent protective devices like circuit breakers or fuses to trip and clear the fault. This is a critical safety feature that protects people and equipment from electrical shock and fire hazards. The requirement to pigtail grounding conductors ensures that the grounding path remains intact even if a device, such as a receptacle, is removed. Without pigtails, removing a receptacle could break the grounding continuity for other devices downstream, potentially creating a safety hazard. The size of the grounding conductor is also important. Section 250.122 of the NEC specifies the minimum size of equipment grounding conductors based on the rating of the overcurrent protective device protecting the circuit. Using an undersized grounding conductor can limit its ability to effectively carry fault current, increasing the risk of equipment damage or electrical shock. While the NEC only requires grounding conductors to be pigtailed, the International Brotherhood of Electrical Workers, IBEW, may have additional requirements for their members. It is possible that a local IBEW chapter has adopted a policy requiring pigtails on all conductors, but this is not an NEC requirement. These additional requirements often stem from a desire to enhance safety and ensure consistent wiring practices among their members. The IBEW often emphasizes best practices that go beyond the minimum requirements of the NEC. This can include requiring pigtails on all conductors to simplify troubleshooting, improve reliability, and reduce the risk of accidental disconnections. Such practices, while not mandated by code, can contribute to a higher standard of workmanship and electrical safety. The picture in the NEC handbook showing a receptacle wired with hot and grounded conductors coming in and out on the same side is an example of a legal wiring method. This arrangement allows for easy removal of the receptacle for servicing or replacement without affecting the continuity of the hot and grounded conductors. This is because the wires are connected to the receptacle terminals in a way that maintains a continuous circuit, even when the receptacle is removed. The handbook is designed to provide clarity and guidance on how to properly apply the NEC. The examples and illustrations in the handbook are intended to demonstrate acceptable wiring methods and interpretations of the code. They are not intended to introduce new requirements or contradict the existing code language. The key takeaway is that based on the NEC, only grounding conductors are required to be pigtailed. However, a local IBEW chapter may have additional requirements. It is always advisable to check with a local IBEW representative for clarification on their specific requirements. Understanding the difference between NEC requirements and IBEW practices is crucial for electricians to ensure they are complying with all applicable rules and regulations. The NEC provides the minimum safety standards, while the IBEW may implement additional requirements to enhance safety and workmanship. To elaborate further on the NEC sections mentioned, let's delve into the specifics of section 250.148b and section 250.122. Section 250.148, titled Continuity and Attachment of Equipment Grounding Conductors to Boxes, addresses the requirements for maintaining grounding continuity in electrical boxes. Subsection B, grounding conductor continuity, specifically deals with situations where multiple equipment grounding conductors are present. The language in 250.148b is very precise. It states that where more than one equipment grounding conductor is connected to an equipment grounding termination, a grounding conductor shall be used to connect the grounding conductors to each other. This means that if you have multiple grounding wires entering a box and terminating on a grounding screw or bus bar, you must use a separate grounding conductor, a pigtail, to connect all of these grounding conductors together. This ensures that even if one of the grounding conductors becomes disconnected from the termination point, the grounding path for the other conductors remains intact. The pigtail acts as a redundant grounding connection, providing an extra layer of safety. The second part of 250.148b states that the pigtail shall be sized in accordance with 250.122. This is a critical requirement that ensures the pigtail is capable of safely carrying fault current. Section 250.122 provides detailed tables and guidelines for sizing equipment grounding conductors based on the rating of the overcurrent protective device protecting the circuit. For example, if a circuit is protected by a 20-amp circuit breaker, Table 250.122 in the NEC would specify the minimum size of the equipment grounding conductor. The pigtail used to connect the grounding conductors must be at least this size. It is important to note that the size of the grounding conductor is not solely determined by the size of the circuit conductors. It is based on the rating of the overcurrent protective device. This is because the grounding conductor must be able to safely handle the maximum fault current that the circuit breaker or fuse is designed to interrupt. Now let's examine the exceptions to the pigtailing requirement. The first exception states that pigtails are not required if the grounding conductor is part of a metal raceway or enclosure that ensures grounding continuity. This means that if the electrical box is metal and the wiring is run in metal conduit or cable with a metallic sheath, the metal raceway itself can serve as the equipment grounding conductor. In this case, the grounding continuity is maintained through the physical connection of the metal raceway components. However, it is still important to ensure that all metal boxes and enclosures are properly bonded together to create a continuous grounding path. This can be achieved by using grounding bushings and bonding jumpers. The second exception states that pigtails are not required if the grounding conductor is part of approved flexible cord or cable. This exception applies to situations where flexible cords or cables are used to connect equipment to a power source. In these cases, the grounding conductor within the flexible cord or cable is considered to provide adequate grounding continuity. However, it is important to ensure that the flexible cord or cable is properly terminated at both ends and that the grounding conductor is securely connected to the equipment and the grounding system. In addition to the NEC requirements, it is important to consider the potential for local amendments or interpretations of the code. Some jurisdictions may have adopted local amendments that modify or add to the NEC requirements. It is always advisable to check with the local electrical inspector or building department to determine if there are any local amendments that apply to your project. Furthermore, the electrical inspector has the authority to interpret the code and make judgments on whether or not a particular installation meets the requirements of the code. It is important to work closely with the electrical inspector to ensure that your installation is in compliance with the code and any applicable local amendments. In summary, the NEC requires pigtails on grounding conductors in most situations to ensure grounding continuity. However, there are exceptions for metal raceways and flexible cords or cables. It is also important to consider the potential for local amendments or interpretations of the code. By understanding these requirements and working closely with the electrical inspector, you can ensure that your electrical installation is safe and code compliant. Now let's shift our focus to the IBEW and their potential additional requirements regarding pigtails. As mentioned earlier, the IBEW may have policies or best practices that go beyond the minimum requirements of the NEC. These additional requirements are often aimed at enhancing safety, improving workmanship, and ensuring consistency among their members. One common reason for the IBEW to require pigtails on all conductors, not just grounding conductors, is to simplify troubleshooting. When all conductors are pigtailed, it becomes easier to isolate and test individual circuits without disrupting the continuity of other circuits. This can save time and effort when diagnosing electrical problems. Another reason is to improve reliability. Pigtails provide a more secure and reliable connection than simply wrapping wires around a screw terminal. The wire nut or other approved splicing method used to create the pigtail provides a greater contact area and reduces the risk of loose connections. Loose connections can cause arcing, overheating, and even electrical fires. Requiring pigtails on all conductors can help to minimize the risk of these problems. Furthermore, pigtails can make it easier to replace or service devices. When a device is wired with pigtails, it can be easily removed and replaced without disturbing the wiring of other devices. This is particularly important in commercial and industrial settings where downtime can be costly. Finally, requiring pigtails on all conductors can promote consistency and standardization among electricians. When all electricians followed the same wiring practices, it becomes easier to ensure that installations are done correctly and safely. This can also reduce the risk of errors and misinterpretations. It is important to note that the IBEW's requirements regarding pigtails may vary from local to local. Each local chapter has the autonomy to establish its own policies and best practices. Therefore, it is essential to check with the local IBEW chapter to determine their specific requirements. Even if the IBEW does not have a formal policy requiring pigtails on all conductors, they may still recommend it as a best practice. Many experienced electricians prefer to use pigtails on all conductors even if it is not required, because they believe it results in a safer and more reliable installation. In addition to pigtails, the IBEW may also have other requirements related to wiring methods, materials, and workmanship. These requirements are often based on industry best practices and the IBEW's commitment to providing its members with the highest level of training and skills. It is important for electricians to stay up to date on the latest IBEW requirements and recommendations. This can be achieved by attending training courses, reading industry publications, and participating in local IBEW meetings. By staying informed, electricians can ensure that they are providing their customers with the safest and most reliable electrical installations possible. In conclusion, while the NEC only requires pigtails on grounding conductors, the IBEW may have additional requirements or recommendations regarding pigtails on all conductors. It is important to check with the local IBEW chapter to determine their specific policies and best practices. By following the NEC requirements and the IBEW's guidance, electricians can ensure that their installations are safe, reliable, and code compliant. Let's also consider the NEC handbook and its role in understanding code requirements. The NEC handbook is a companion document to the NEC that provides additional explanations, illustrations, and examples to help users understand and apply the code. The handbook is not part of the code itself, but it is a valuable resource for electricians, inspectors, and other electrical professionals. The handbook often includes pictures and diagrams that illustrate acceptable wiring methods and interpretations of the code. These illustrations can be particularly helpful for visualizing how the code applies in different situations. The picture in the NEC handbook showing a receptacle wired with hot and grounded conductors coming in and out on the same side is an example of one such illustration. This illustration demonstrates that it is permissible to wire a receptacle in a way that allows for easy removal and replacement without disrupting the continuity of the hot and grounded conductors. This wiring method is commonly used in commercial and industrial settings where receptacles may need to be replaced frequently. The handbook also includes explanations of the code's intent and purpose. These explanations can help users understand the reasoning behind the code requirements and how they are intended to be applied. The handbook also includes examples of common code violations and how to avoid them. These examples can be particularly helpful for trainees and apprentices who are just learning the code. It is important to note that the NEC handbook is not a substitute for the NEC itself. The handbook is intended to be used as a supplement to the code, not as a replacement. The code is the final authority on what is required. However, the handbook can be a valuable tool for understanding the code and applying it correctly. In addition to the NEC handbook, there are many other resources available to help electricians understand the code. These resources include training courses, industry publications, and online forums. It is important for electricians to take advantage of these resources to stay up to date on the latest code requirements and best practices. By understanding the code and following best practices, electricians can ensure that their installations are safe, reliable, and code compliant. To summarize, the NEC handbook is a valuable resource for understanding and applying the NEC. The handbook includes explanations, illustrations, and examples that can help users visualize how the code applies in different situations. The handbook is not a substitute for the code itself, but it is a valuable tool for electricians, inspectors, and other electrical professionals. Finally, let's reiterate the importance of checking with your local IBEW representative for clarification on their specific requirements. As mentioned earlier, the IBEW may have policies or best practices that go beyond the minimum requirements of the NEC. These additional requirements are often aimed at enhancing safety, improving workmanship, and ensuring consistency among their members. The IBEW is a labor union that represents electrical workers in the United States and Canada. The IBEW provides its members with training, education, and other benefits. The IBEW also advocates for the rights and interests of its members. The IBEW is committed to providing its members with the highest level of training and skills. The IBEW also works to promote safety in the electrical industry. The IBEW has a long history of advocating for safe working conditions and fair wages for electrical workers. The IBEW is a strong advocate for the NEC and other safety standards. The IBEW also works to ensure that its members are properly trained and qualified to perform electrical work. The IBEW is a valuable resource for electricians and other electrical professionals. The IBEW can provide its members with access to training, education, and other benefits. The IBEW can also help its members stay up to date on the latest code requirements and best practices. If you are an electrician, it is highly recommended that you join the IBEW. The IBEW can provide you with the resources and support you need to succeed in your career. In conclusion, the NEC requires Pigtails on grounding conductors in most situations to ensure grounding continuity. However, there are exceptions for metal raceways and flexible cords or cables. The IBEW may have additional requirements or recommendations regarding pigtails on all conductors. It is important to check with your local IBEW representative for clarification on their specific requirements. By following the NEC requirements and the IBEW's guidance, electricians can ensure that their installations are safe, reliable, and code compliant. Remember to consult the most recent edition of the NEC and any applicable local amendments to ensure compliance with current regulations. Safety should always be the top priority when working with electricity.